Good morning, children. Let's proceed with the remaining topics in chapter 10, circles. The very important theorem, the proof has to be learned for the exam. The angle subtended by an arc at the center is double the angle subtended by it at any point in the remaining part of the circle. This is the statement of the theorem. The angle subtended by an arc. So let's represent the three different forms of arc, that is number 1 minor arc, number 2 semicircle, and number 3 major arc. So let PQ represents a minor arc, let PQ represents a semicircle, and let PQ represents a major arc. And now the angle subtended by an arc at the center. That means this arc will subtend an angle at the center, angle POQ. This arc also subtends an angle at the center, POQ. This arc subtends an angle at the center. The angle subtended by an arc at the center is double or twice the angle subtended by it at any point in the remaining part of the circle. Let A be a point in the remaining part of the circle. Case 1 here. Let A be taken here. Let A be a point taken on the remaining part of the circle in all the three cases. And now the theorem says that the angle at the center is double the angle in the remaining part of the circle. That means angle POQ is equal to 2 times angle PAQ. Here also angle POQ is equal to twice angle PAQ. Angle POQ is equal to twice angle PAQ. That is what the theorem says. That is, the angle subtended by an arc at the center is double the angle subtended by it at any point in the remaining part of the circle. Let's write the given a circle with center O, PQ is an arc, and A be any point in the remaining part of the circle. And in all the three cases, what is to prove? To prove is angle POQ is equal to twice angle PAQ. Now, in all the cases, let's join AO and let it be the point M here. Let's join AO and extend it. Here. So as construction, join AO and extend it such that AM is a ring. And now in all the three cases, let's prove a general condition. Proof. In all the three cases, in all the three cases. Angle POM. Angle POM is equal to, in triangle OAP, if you take POM is an exterior angle, it is by the property exterior angle is equal to sum of interior opposite angles. Angle POM is equal to angle OAP plus angle OPA. Similarly, angle QOM is the same as angle OAQ plus angle OQA by the property exterior angle is equal to the sum of interior opposite angles. But what can you say about OA and OP? It is the radius. Similarly, OA is equal to OQ also is a radius, which shows that angle OAP and angle OPA are equal by the property angle opposite to equal sides in a triangle. But OA is equal to OP and OA is equal to OQ radius. Therefore, angle OAP is equal to angle OPA and angle OAQ is equal to angle OQA by the reason angles opposite to equal sides. Immediately what will happen to angle POM and angle QOM is angle POM is equal to twice angle OAP and angle QOM is equal to twice angle OAQ. This is the general concept for all the three cases. Let's take all the three cases separately to prove that angle POQ is equal to twice angle PAQ. Case 1 and case 2, that means both whether it is a minor arc or a semicircle, how to prove it. If you refer the picture here, angle POM plus angle QOM is equal to twice angle OAP plus twice angle OAQ, that is angle POM plus angle QOM. Similarly here also POM plus angle QOM is equal to twice angle OAP plus twice angle OAQ. What is angle POM plus angle QOM from this figure? It represents angle POQ, the total. Similarly here also angle POM plus angle QOM is representing angle POQ is equal to twice angle OAP plus angle OAQ, which is equal to twice angle OAP plus OAQ is representing PAQ. Look at this figure also. OAP plus OAQ will give you twice angle PAQ. That is, angle POQ is equal to twice angle PAQ is proved in both the cases. Let's go with case 3 where PQ is a major arc. Case 3 when arc PQ is a major arc. From this figure, angle POM is equal to, angle POM is the same as I told you, AOM is a ray. Angle POM is equal to 180 minus angle POA. The reason is by linear pair axiom. Similarly, angle QOM is equal to 180 minus angle QOA by linear pair. If you add it, angle POM plus angle QOM is equal to 180 plus 180 is 360 minus angle POA plus angle QOA. POA plus QOA is giving you POQ. Angle POM we have already taken as twice angle OAP plus QOM is twice angle OAQ is equal to 360 minus angle POQ. What is the meaning of 360 minus angle POQ? It is reflex angle POQ. That is, reflex angle POQ is equal to twice angle OAP plus OAQ or twice angle PAQ. Twice angle PAQ. It shows that whenever you have a major arc, reflex angle POQ is equal to twice angle PAQ. Thus, the theorem is the measure of an arc is always the angle POQ. Angle POQ is always equal to twice angle PAQ, where A represents any point in the remaining part of the circle apart from the arc you have considered. Thus the theorem, the angle subtended by an arc is double the angle subtended by it at any point in the remaining part of the circle. This proof has to be studied for exam. Now the two more theorems can be derived with the help of this particular theorem. The second one is angle in a semicircle. Angle in a semicircle is always a right angle. That means you are given a circle with center O. Let AB represents the diameter. If AB represents a diameter, arc AB will be a semicircle. Let C be any point in the remaining part of the circle, which shows that angle ACB will be half of 180 degree, which is equal to 90 degree. Semicircle, the angle at the center is 180. By the theorem, angle AOB is equal to twice angle ACB. Angle AOB is 180, twice angle ACB, or ACB will always be 90 degree. That is the theorem, angle in a semicircle is always a right angle. And now the next theorem is angles in the same segment. Angles in the same segment are equal. You are given a circle with center O. Let AB represents an arc, and let D and E be 2 points in the remaining part of the circle. You can form angle AOB and angle ADB. Same angle AOB with angle AEB also. Angle AOB is equal to twice angle ADB by theorem 1. Also, angle AOB is equal to twice angle AEB. From that you will get twice angle ADB and twice angle AEB are equal, which shows that angle ADB and angle AEB will always be equal, which shows that angles in the same segment are equal. The fourth theorem in this lesson is regarding a cyclic quadrilateral. What is a cyclic quadrilateral? A quadrilateral whose all four vertices lie on a circle is called a cyclic quadrilateral. What is the property of a cyclic quadrilateral? In a cyclic quadrilateral, the opposite angles are supplementary. If ABCD represents a cyclic quadrilateral, the pair of opposite angles, angle A plus angle C is 180. Second pair, angle B plus angle D is also 180 degree. So what is the theorem? In a cyclic quadrilateral, opposite angles are supplementary. That is, angle A plus angle C is 180. Also, angle B plus angle D is equal to 180 degree. So, these are the theorems which are applicable in exercise 10.5. Exercise 10.5, question number 1. In the figure, A, B, C are 3 points on the circle with center O. A, B, C are any 3 points on a circle with center O such that angle BOC is equal to 30 degree, angle AOB is equal to 60 degree. If D is a point on the circle other than arc AC, find angle ADC. So, according to the question, angle AOB is 60 degree and angle BOC is equal to 30 degree. What is to find is angle ADC. As per the theorem, angle ADC and angle AOC are the two angles subtended by arc ABC at the center as well as any point in the remaining part of the circle. So, the relation is angle AOC is twice angle ADC, or angle ADC is half of angle AOC. So, the proof: first, find out angle AOC by adding AOB plus BOC. Angle AOB plus angle BOC is equal to 60 plus 30, which is equal to 90 degree. That is, angle AOC is equal to 90 degree. And now, therefore, angle ADC is equal to half of angle AOC. You have to write the statement of the theorem. Angle at the center is double angle in the remaining part of the circle. Angle at any point in the remaining part of the circle, that is half of angle AOC is 90 degree, 90, which is equal to 45 degree. It is a direct application. Question number 2. A chord of a circle is equal to the radius of the circle. In the figure you can see AB is a chord and it is equal to the radius, means OA and OB represents the radius. The given is AB, OA and OB are equal. That is, OA equal to OB is equal to AB shows that triangle AOB is equilateral. Now, find the angle subtended by the chord at a point in the minor arc as well as any point in the major arc by the chord AB. This is the chord AB. The chord is here. If you represent a point, that is in the major arc, and E represents a point in the minor arc. So, D and E are 2 points in the major arc and minor arc respectively. what is to find is angle ADB and angle AEB. And now the proof, as we have explained, since AB is equal to OA is equal to OB, triangle AOB is equilateral. What will be the measure of each angle of an equilateral triangle? It is 60 degree. That is, angle AOB is equal to 60 degree. If angle AOB is 60 degree, what will be the measure of angle ADB in the major arc? It is angle ADB is equal to half of 60, which is equal to 30 degree. The reason, angle at the center is double angle in the remaining part of the circle. If you observe carefully, DAEB is a cyclic quadrilateral. What are the pair of opposite angles? One pair is D and E. What is the relation in a cyclic quadrilateral? Opposite angles are supplementary. So, in cyclic quadrilateral, DAEB, angle ADB or angle D plus angle E is equal to 180 degree. That is, 30 plus angle E is equal to 180, or angle E is equal to 150 degree. The reason, opposite angles of a cyclic quadrilateral. Another method of finding angle E is reflex angle AOB is 360 minus 60, 300, and half of 300, that will give you 150. There are two different methods. Question number 3. In the figure, angle PQR is equal to 100 degree, where P, Q and R are points on the circle. You have to find out what is angle OPR. OPR. This angle has to be found out. If you know angle PQR, immediately let's put this angle as angle 1 and this angle as angle 2. So, proof angle PQR is equal to 100 degree. Therefore, angle 1 is equal to 2 into 100, which is equal to 200, by the reason angle at the center is double angle at any point in the remaining part of the circle. Therefore, immediately angle 2 is equal to 360 minus 200, which is equal to 160 degree. And now, what's the relation between OP and OR? They are the radii. OP is equal to OR radius. Therefore, in triangle OPR, immediately angle OPR and angle ORP also will be equal. Let's name it as angle OPR is equal to angle ORP is equal to X. What's the reason? Angle opposite to equal sides. Equal sides. Apply angle sum property. 160 plus X is equal to 180. Angle sum property of triangle. 2x is equal to 180 minus 60 is 20, or x is equal to 10 degree. That is, angle OPR is equal to 10 degree.